it's in JavaScript, and it's fascinating to me.
Really?
Like, it's really, really good. Maybe I'll post it actually in the...
That sounds good.
Because I read that and I was just like, wow. Yeah, that's one. But I heard that he wanted to get basically like type annotations and stuff in Max. He was just working a couple of Linux packets, and that's actually very clever about using. So that working with JavaScript. This is so ghetto.
Yeah. It's funny you say that because like first thing I think the first thing I think of like when I hear it, it's like I'm going to use that for
Hello?
Shit. Well, it's interesting, like in like cursive and IntelliJ, it's very smart about business stuff now.
Like IntelliJ for Java or for Clojure? For Clojure? Okay. Yeah. Yeah. I don't know. Like basically everything I've used for Python and stuff like that, type confusion, absolute nightmare. And
yeah, that's been my experience with most dynamic languages.
And like if any of them were languages that I actually didn't hate using,
hello.
I probably would just
can you hear us?
Take that, you know? Yeah. So I don't want to like.
Can we hear you?
You know?
Yep.
Keep on filling the screen back.
I can hear you. Excellent. Okay.
I may have a laggy computer though. That's probably what's going to happen for the rest of the time.
Right. I think we're in a similar situation.
I was having trouble running core typed while having a Hangout on just because I have such a bad laptop. I blame the JVM, but really it's because core typed is a bit of a hog.
Well, it's good to see you. Thank you for hanging out with us tonight.
Good to see you all. I was just going to ad-lib a bit of the basics of core typed. So I guess, has anyone used core typed or seen any of my talks or anything like that?
About half of us have seen your strange loop talk and maybe another talk. And maybe a quarter have actually used core typed in one capacity or another.
Okay. So, logistically, Google Plus sometimes doesn't like it when you type. So, I don't know, maybe say something if it's clear that I'm talking to myself and you can't hear me. I won't be able to see the chat because I'll be on another window. But I'll try and screen share.
Okay. Hit to him for now. Is that what you were going to say? Yeah.
But if you don't do present to everyone, because that might show it to him. Just click on his square chart.
Okay.
Is that working?
Yeah.
Okay. Surprisingly good.
Okay, that's good. Good start.
Can everyone read that? Yes.
Build it.
All right. Okay, so Typed Clojure is an optional type system for Clojure, and okay, so I had a little bit of a test run beforehand. I'll just scroll up and show you what I did. So I have I just created a Lineagen project, Toronto demo, and I should probably show you my project, .clj. So I've added a dependency string to core typed. So core typed is just another jar that you can bring into your Clojure projects. I like to think of it as a linter. So, and in practice, it really is quite like a linter in that core type just gives you the tools to start type checking things, but it doesn't enforce it. So, yeah, the workflow is very much like you're at the REPL, you're programming something, and then you type check it. It's not like an implicit step. And yeah, we'll see this as I go along. So we're just going to play around with a few very simple forms in core typed. So one of the goals of core typed is to type check regular Clojure code and attempt to do it in a way that we can prevent common errors. So to get started with core typed, I've got a require, and this is our clojure.core.typed is the, I guess, the master namespace. This is where you're always going to start. So we've just jumped into Clojure core typed. So everything we're going to see from here is in the namespace Clojure core typed. All right. So we have a macro called CF. Let's bring in something. Clojure.REPL. I think. Right, so we have this macro CF, and here's a few examples of it, and it stands for check form, and you can call it in two ways. One way is to just pass it a Clojure form, and it'll return the inferred static type for it, and you can also add an expected type, which will help drive type checking. So here's an example. We can type check 1. So the output is a little complicated. So here's our static type here. We've got our form statically type checked to value 1. So this isn't very useful to look at. So let's just say we're expecting 1 to type check as a long. Whoops. Let's try that. Right, so we have this macro and form, which is like a static type assertion. So we assert that 1 is of type long, and core typed agrees with me. And if I tried to do something else, like that 1 is a string, we're going to get back a type error, and unfortunately a few redundant ones. But let's just pretend this is just 1. But we've got a type mismatch. So in the form 1, we're expecting an instance of Java lang string, and we're actually getting a value 1. So this is a common kind of state for type errors. We're expecting a single type, and we're expecting a type, we're actually getting a different type. It'll give us a form and some line numbers. The line numbers themselves aren't very useful in the REPL. You just end up getting like line number 1. But yeah, when you're using core typed usually in a file, yeah, it'll tell you exactly where the errors are. So one thing that's interesting coming from Java is that core typed kind of separates the two notions of null and reference types. So in other words, core typed reference types are non-nullable by default. Or no, they're just non-nullable. So let's see what that means. We have a type for nil is the value nil. And yeah, I should just say, just ignore everything to the right here. This is just extra stuff that core types inferred. So this is something that you won't see in Java, because nil, which is exactly the same as the null pointer, so null in Java, is the same as nil. Doesn't have an explicit type in Java. It's actually implicit in every reference type. So this basically means Java's type system doesn't prevent null pointer exceptions. So in practice, this means you can't, let's say, can't say that nil is a long. So we have that we're expecting an instance of long, and we're actually getting nil. So this is something that you could write in Java, but core typed statically prevents any leakage of nil into code that doesn't expect it. So we can still use this convenient idiom of having a null value, but we get back the convenience with union types. So we can say that nil is a nullable long, which is fine. But it gets kind of interesting because in Clojure code we have conditionals, and they direct the program flow. And with the program flow, Clojure programmers implicitly have kind of types narrowing down different branches. So I'll show you what I mean. So say we have a let binding. Well, let's just put A as nil. So, for example, if we have a value that is possibly nil, we would use a conditional. So when A, do something with A in here. So there's some implicit control flow. This is there's some implicit type information that comes with this control flow. So if we're in this body here, this clearly means that A is not null, or it's not false as well. So Typed Clojure has to follow this logic, and it does so with an inference technique called occurrence typing from type bracket. So I'll just show you that in action. So might be a little messy. So ANForm also can, as well as inserting a static type, it can also lose type information. So we can forget that this value is just nil, and let's say that it's the best we know about it, it's either nil or a long. Okay. So at this point in the program, and at this point, the most core type knows about A is that it's a union of nil and long. And actually, we have a nicer syntax for this. This nil. So actually, there's something I haven't told you yet, which is this let is actually clojure.core.type/let, because we're in this type namespace. And a lot of the macros that are in core typed have some extra annotation. So here's an example. So after a binder, you can have this is type keyword, and then a type, and then you put your binder, your right-hand side there. So,
what is that on the right-hand side? You called it a binder?
no, as in the right-hand side of the let. I didn't mean to say binder. I think this whole thing is the binder, and this is the left-hand side of the let that we normally write. This is the right-hand side, as in the initial value of the let binding, and then this is our static type, and it's the same as the and form that I showed before.
Okay.
Right. Right. So if we type check this particular call here, you'll see that this can possibly throw a null pointer exception if we believe that A can be either nil or long, because int has to take a number, and we're passing it nil. So we get this kind of large error message. I'll help you read this, but first thing we need to know is that core typed kind of reuses the compiler, the Clojure compiler. So by the time core typed gets to your code, it's going to be fully macro expanded, fully inline, and all the magic that the Clojure compiler does. So by the time core typed gets to this form here, this inc call is going to be a Java method, as it is in regular Clojure. So inc has turned into Clojure lang, I'm missing a bit. Yeah, dot numbers /inc. so you can see that there are a few different ways that we can call int, and this error message attempts to format it in a way that you can comprehend. But basically, there are three pieces of information that you want to look at. Sometimes four. Here we've got three. So the first one is the domain, and that is the expected type that we're expecting for our parameters. So we can call int with a long, a double, and any integer, which is just a union of all the different integer types in Java, and finally we can call it with a Java-lang number. And actually, these are the output types that correspond to these input types. So if we put in, if CoreTyped infers that we give it a long, then it knows that inc returns a long. And if it takes a double, then it returns a double, etc., until we get to the base case. So this is kind of like pattern matching in a way. And in a way, it's quite similar to pattern matching because CoreTyped just it infers the type of the argument and then matches it against the parameters. So here's our argument type: union nil and long. So if we remember, this is this argument here. Remember, we've assigned it this type union nil long. So this is where CoreTyped tells us this information. So what it's going to do, it's going to try the first domain and see if union nil long is a long, and it's not, because CoreTyped treats nil as just another value. It has a completely different type than a reference type. So clearly, none of these domains fit. So what do we do when we need to fix this kind of code in Clojure? Well, we use conditional branching. So we'd use something like this. So, So we use a when statement, and actually, if you use when is generally a great tool to avoid null pointer exceptions in Clojure. And if you use the threading macros like sum, arrow, and when, and the as threading macros, you'll find that you'll get a lot less null pointer exceptions than you might in Java. But still, there are times when you might forget to add a particular check, and this is where CoreTyped will help you. So if we just follow the logic here, when we get to this conditional branch, A is going to be either nil or long, and if we ever get to the body, then we know that it's a long. So, long story short, it type checks either being long or nil, and to be more explicit, this when is exactly the same as if a nil, right? All right. So in Clojure, another very common construct is a function. And there are a few tricks with type checking functions with CoreTyped. Ooh, okay. How can I make this more readable? Any to any? Nope. All right, okay. So I've asserted that this form is like any to any. So this is the parameters, and this is the domain. And CoreTyped has verified that here. So actually, the point I wanted to make was with this particular form. So we're type checking this fun without any type information, and we get back this type here, any to any, and some extra stuff, which we'll ignore. But actually, this is kind of interesting because clearly this should be something like for all types X, then we get back X. And if you've ever used a typed language with global type inference, you might expect something like this, like a nice polymorphic type if you've ever used the let polymorphism in OCaml or Haskell, you'd expect the type for the identity to be something like, yeah, for all types X returns X. But unfortunately, or depending on how you look at it, fortunately, we have local type inference in typed Clojure. And there are a few rules that come with that. And one of the rules is that you have to annotate function parameters. So again, we've got our special Clojure core type /fun macro, which has some nice syntax, so we can annotate it like this. So, all of these types, so ugly. Sorry, it's something I need to fix. But anyway, we've annotated it to take along and return along, and kind of even if it's bleedingly obvious that it takes along, unfortunately the local type inference algorithm just simply doesn't like it. So clearly this is going to return 1 or a long, but it returns any. And basically this is the same as core typed assuming that the first argument is of type any. And this actually gets quite annoying. So for example, you wanted to do something like map. Just going to type check. Right, so we map over a map of functions over some sequence, and we're expecting it clearly returns a map of numbers, but unfortunately it doesn't. It returns it returns a sequence. You would expect it to return a sequence of numbers. Unfortunately, it returns a sequence of type any. So yeah, so one way we can fix this is to have an annotation here. And another way is we can have an and form for this particular function that explicitly tells the whole type. But yeah, we don't need to add this range position, right? We can simply infer it using the local type inference rules. All right. I think that's enough.
Is that an issue with occurrence typing in general, or just?
That is actually an issue with local type inference. There's literally an algorithm called local type inference, invented about 15 years ago by Pierce and Turner. If you've ever read Types and Programming Languages, it's the same Pierce as that.
Right.
But Scala used the same algorithm. And a lot of these optional types that are popping up, I'm sure Flow uses something similar. Basically, once you have subtyping, you kind of have to throw out any kind of global type inference that you might like to have, like in Haskell or OCaml, and you end up with local type inference. Yeah, and it's a well-known limitation. So occurrence typing kind of works really well with local type inference, but yeah, it's really local type inference's fault that we can't infer better types for these positions. Yeah, a common question is, can we fix that? And my answer is, I don't really know, but I'd love to work more on it.
Right.
But whether we can completely 100% infer Clojure code, types for Clojure code, I don't know. I don't think so. It's pretty unlikely. Like, one of the main activities of core type is actually annotating code, and of course that's the one thing that's really boring, especially if you're porting old code and you have to reverse engineer the code. So I guess the burden of annotation is sometimes overseen, like because you get these nice strong type invariants, you can give the correct annotations, but still it's still pretty annoying to have to add annotations.
Right. How did Typed Clojure know that the inc function took the domain and range that it took?
Right. So I gave a type for fee, so we can see. Um, Right, so we can just type check things and ask what type you think the type is, and we get back this, it's called a function intersection, and basically the interface that is behind invoking functions in Clojure is called Clojure lang hyphen, and this is why it's called hyphen. And here are our core arrays, and somewhere in the core type code base, there's a couple of thousand lines that annotate the Clojure core namespace,
Okay.
and they're basically unchecked. So I'm assuming that Clojure will adhere to this type.
Right.
It usually does.
You essentially went through and manually annotated all of the core functions.
Yeah, I'll show you it. It's an impressive piece of work.
So speaking of that, you mentioned I think in Twitter once that you were thinking of starting maybe like a repository with just annotations for popular libraries.
Yeah. So TypeScript takes this approach where it just has a big monolithic repository of annotations. But I don't know, like we have nice versioning tools in Clojure, right? We have Maven for deploying jars. It just seems like a big hammer for this problem, right? But yeah, we definitely need repositories with annotations, but it would be even better if they were packaged with the actual library. I mean,
I agree.
it would be better. Because
libraries mutate, right? And every time a release happens, tracking the central is probably really difficult.
that's exactly right. And yeah, we don't know the type. Yeah, like for example, in the Typed Clojure distribution, I type check core async, right? And if that changes, then yeah, I'm pretty screwed. I don't know what version the user is using. You can't really look up that information. What core async. I mean, even if I could, it would be a nightmare. So I basically fix the annotations for a particular version of core async. And yeah, I mean,
Do you check like one way? Do you check version numbers for libraries? Is there any way to do that?
there isn't a way to do that at the moment. One compelling use case is actually version numbers for Clojure core. Like, because if you think of transducers, right? So in 1.7, I'm going to have the type for map, which I'll show you.
Yeah, this was part of Rick Schicke's Strange Loop talk, right? How do you type transducers?
Oh, it's not that. But he was being quite.
He was being a little facetious.
No. He was setting a very, very hard problem, and I'm not interested, particularly in solving that in the next couple of weeks, for example. Like, as a long-term goal, it is a very fascinating thing. But basically, in Clojure 1.7, map's going to have like an extra parity that, I don't know, what is it? It takes some sort of transducer from C to A, and then, oh no, it takes the same thing and returns some transducer. Anyway, if we were using this to type check Clojure 1.6, then we have this extra bogus arity. And yeah, I'm thinking this is something I need to add to the type annotation syntax. Yeah, and maybe I don't know how granular we want to make it. So maybe we want something like 1.6. I don't know. 1.6 is this, and 1.7 is, or whatever.
Right.
I'll have to think about that. Yeah, I haven't really fleshed out exactly what transducers look like. Let me just see if I have some half-broken code so you can see vaguely what it looks like.
The CLJX might be useful for different annotations for different versions.
It is actually useful for different for annotations between ClojureScript and Clojure because
Right, they differ sometimes between.
right and you know how there's a trick with macros where you can use Clojure.core macros in ClojureScript and automatically translates it to Clojure CLJX. Yeah, right. So there's the same trick with types. So we have a namespace. Clojure CLJS.core.type, and in ClojureScript, if you run the type checker, the core type checker, and you refer to a Clojure.core.type, it'll you know, transfer automatically. But yeah, all the I guess the weirdness between if the syntax don't match up that well, then something like CLJX would be good for that. Yeah, so you'd say that in ClojureScript it's this particular type. But yeah, I haven't really tested that out very much, but I think someone has. Yeah, actually, a very amusing hack. About 3 months ago, some guy asked me about the ClojureScript implementation of core types, and he wanted to type check some ClojureScript code. And I was basically saying, look, maybe this isn't what you want to do because core types on ClojureScript isn't that mature. So basically what he did, he used CLJX to emit Clojure code so he could type check it with core types, but he never used the Clojure code. And it was a very amusing hack.
Right.
Yeah. But yeah.
So, in general, what's the state of the art with Typed Clojure and ClojureScript?
It's 60% towards being usable. I don't know. You end up. So actually, the biggest problem right now is that interop just doesn't work because I'm being very conservative and I don't want to implement anything before it fully works. Unfortunately, you just can't use JavaScript interop. But a lot of the other things work, like annotating functions. I don't even know if I have an example. But unless you're very enthusiastic, I would recommend not using it at the moment.
Right.
I guess like some people are using like Prismatic with their schema.
Say again?
Like I think Prismatic are using core type with a schema, right?
I don't think they are. No.
Maybe not. Maybe I'm confused.
I haven't been told they're using core type. Okay.
Are you keeping a record of people who are using it in the projects or projects that have been annotated?
Kind of. Back of my head somewhere. I think the people who hang out on IRC have 1 or 2 projects, but I think in my Strange Loop talk I talk about Circle CI, which I think fairly obviously have the biggest installation of Typed Clojure.
Right.
And I think Sean Caulfield is interested in core types, and I think he's dabbled in it in the World Singles code base. But yeah, a lot of the attempts at using core types that I hear about, usually in rants on Twitter, are that the core type isn't quite. It's a bit too annoying at the moment. Like it's a bit too pedantic, and it's kind of designed to be that way. So that there's a bit of room for another tool that is perhaps somewhere between Untyped Clojure and Typed Clojure that kind of gives you some hand-wavy experience. Kind of like the Erlang dialyzer, which uses this type checking technique called success typing, and it's basically a very optimistic type checker, and it only tells you type errors when it knows that 100% of the time something is going to fail, and you basically you don't catch as many errors. So there's room in the design space for Clojure to have its own dialyzer, but core typed is very much about sound type checking, being able to prove invariants like null pointer exceptions.
Right.
So yeah, if you start using core type, then it seems to be a bit too pedantic. It's by design, unfortunately, but also fortunately, if you're type checking, a whole bunch of code, and yeah. So
What was the other type of type checker, sorry?
what was that?
What's the optimistic type checker called? Like the
Success typing.
right?
The dialyzer uses it for Erlang. I think it's like DIALYZER.
Would it be possible to use that with the typed Clojure annotations?
Yeah, I think, but part of the Typed Clojure project has been figuring out what are good ways to annotate Clojure code. And I guess annotating something and then type checking it, you can have the same annotations and have different approaches to type checking. And like if you've been following kind of the gradual typing world in Python, there's this library called MyPy, which I really don't know anything about, but for some reason Guido has been adopting the syntax for MyPy for gradual typing on Python. But some of the people I work with at Indiana are making their own type systems that use the same, a very similar syntax as MyPy, but kind of provide a different guarantees and have something more like gradual typing. So yeah, I guess the answer is you could probably reuse it. And you could probably reuse annotations between schema and typed Clojure, which is an interesting thought because schema is a pretty popular thing. Like it's likely that if you have a big industrial code base that you use schema as like a contract library, so you have a whole bunch of annotations, and it'd be great if Typed Clojure could use that.
Right.
Yeah.
Has anyone done anything with like quick check and Typed Clojure?
Ooh, I think there was a vague attempt in 2012, which I'd never followed up on.
That'd be amazing.
Yeah. So I think this was Kevin Lino. That's how you pronounce his name. He had a system. I think he presented it in ClojureConf 2012, but it basically wrapped up different ways of type checking, different ways of verifying code in like a nice macro. So you could say like type check / contract check / test generative check, and then add a form and then add an expected type, and it would generate test cases, it would type check it, and add the appropriate contracts, things like that. I'm not sure how useful that would be. Actually, for me, the most interesting combination of test check and core typed is to generate but basically to verify the implementations. So it's something that only I would be interested in, basically, so I won't bore you with any of the details.
So, like verifying the type checking annotations?
Right, like, well, no, I mean, like, generating random forms to feed into the type checker, that kind of thing.
Right.
Yeah.
Right.
Things that are really cool to me, but are completely useless to you.
So you don't see any particular leverage in using type annotations to feed into something like test check?
haven't really thought about it, to be honest. It seems like test generative has its own type syntax for its own purposes, and it doesn't seem to make much sense to conflate the two, kind of.
Right.
I'm not sure what it would buy you. Probably not much. And again, like test generative and test check are going to have more expressive types because you can really write your generators and they deal with values. So type closure syntax is not very expressive when you compare it to the contract libraries.
Right.
You can only say things like it's a reference type, it's nil, or it's a function that takes these kind of types. But yeah, like the type closure annotations just wouldn't be expressive enough to test check to be useful.
If that work on kind of expanding occurrence typing to handle dependent types comes there, would that, does that give you expressive enough types?
So actually right now I'm working on answering exactly that question, and I'm not sure of the answer yet. But one problem is, as soon as you add dependent types, you basically have a lot more work to do at the type checker level. Actually implementing things gets pretty difficult. There's some work. In 2012, there was a system called dependent JavaScript, and it's as insane as you might think. It's really cool, but it requires a stat solver in the background to basically solve your type checking. And I guess, frighteningly, we're getting towards that area of needing a stat solver.
Yeah.
I don't know if that's a good thing or a bad thing at the moment.
Are there any particular benefits for occurrence typing being used with Clojure? Or was it just a matter of convenience to choose that form of gradual typing?
So occurrence typing is actually quite limited in that it only really works with immutable things. So that's great. So it actually fits Clojure very well, and it doesn't. The coincidence is that Clojure is very much like Racket, and it's designed to type check Racket code.
Right.
And not everything is immutable in Racket, but a lot of things are treated as if they're immutable. Like you can set bang things. Set bang locals, I think. But basically in Racket, if you don't set bang a local, then type Racket says, it's basically immutable. But in Clojure, we can say that local bindings are immutable because they're final. You can't set bang it.
Right.
So type closure takes that into account in its occurrence typing implementation. I think of a good example. Maybe I have. Maybe I don't. Okay, well, the basic idea is that occurrence typing only works well with immutable things, and that's why it works with Clojure.
Thanks.
I wanted to show you how to kind of start, like, practically with core type. So the first step we've already seen, which is to get our project CLJ working, and unfortunately, typedclojure.org is down now because some pages obliterated it, so I need to fix that.
We noticed that right before the...
Sorry about that. that I knew that was going to happen, but I just did nothing. I had examples.
Yeah.
But
Well, thank you for taking the time with us instead of fixing that.
oh yeah, I'm not looking forward to it, to be honest.
Yeah.
But I'm glad to be here anyway. So yeah, step 0. Here's our current version of Core Typed, and if typedclojure.org is down, find the Core Typed project on GitHub, and it'll have the current version. And we've booted up our REPL. All right, so let's create a new Toronto demo. Core.clj, of course, is the best name for anything. Oh, it already exists. Excellent. Right, so what we're staring at right now is a vanilla Clojure file, right? It's untyped Clojure. And really, there's not much difference between a typed file and an untyped file. They both use the same compiler, the same file extension. Really, the only cosmetic difference, if you're not running the type checker, is that we need to add a namespace dependency to the NS form. So actually, Typed Clojure is pretty particular about this. It needs to have this is basically the flag that says I am a typed file. So let's run check NS. And yeah, Vim is not the best place to present this, but things will be flying in and out of screen. But here's the output that we get from a check NS. So what I just did, I'll go back to it, was run the Clojure core type check NS. And if you pass it 0 arguments, it will type check the current namespace. And if you pass it a symbol or a namespace, it will type check that particular namespace. So, yep, go.
Is there a way to have it kind of like run in the watch mode where it just watches for changes? And
I haven't actually implemented that at the moment. There's a Lineagen plugin. Actually, I've got my own browser here. Why don't I just open it? Sorry, I was stuck in my virtual machine and my browser's outside of it. And wow. You've killed my computer. Come on, you can do it. I need an upgrade. Okay, come on. Alright, anyway, my point was there's a Lineagen plugin called line types, and I'm pretty sure one of the issues is probably what you just told me. I don't know, what are the issues? It's been a while. Nope. Must have rejected it. No, I'm kidding. Alright.
So, a lane plugin would actually be probably the best place for that. Because
oh, definitely, yes. So let me set up just some very basic code, and then I'll show you how to plug it in with the Lineagen plugin, and then hopefully I'll patch the Lineagen plugin so you just get a nice watcher. Alright, so we type checked this, we got back OK, so we could say put in a call to inc just to make sure everything's fine, type check it, and then we get back an error. So this won't be as obvious in Vim, so the thing to read is type errors, and I'm just going to press enter, and it's going to give me like a list of errors, and if I press enter, this is the line number. So this is a terrible resolution for this, but basically there's a shortcut that we can get the error that we saw before. And the error is that it's a call to inc, and we're giving it, sorry for disorienting you if I am. We've got an argument that is type any, and it's not a type number. So this is what errors look like. Anyway, so there's a couple ways we could fix this. Let's make this into an actual function. So the macro for annotating top levels is called tan, or also pronounced an var, annotate var. So it takes a var and a static type. Let's say number to number. And there's a whole bunch of useful aliases in the core type namespace. Yeah, go.
Do you still have the alternate syntax where you can just do zap and greater than and then just put it in line?
I mean, like in this?
No, straight like in the function definition, right? Like instead of doing zapon, you used to be able to do zapon and then like greater than arrow, and do like a type for type zapon.
So the only syntax that there is right now is this.
Okay, so you can just do it in line. Okay.
Yeah, and again, where if you haven't seen this particular trick, I'll show you. So if you want to shadow a closure var, you use refer closure exclude, and then we're going to refer defen into this namespace. And this defen, I'll set up a visual bell and give everyone seizures. Screen won't flash anymore, I promise. So we have defen and our nice little syntax. I'm not a big fan of this, to be honest. People love this, but I like putting the entire static type. And it's really for cosmetic reasons and to pretend that I'm in high school.
Right.
Alright, so a nice expected type check it, little our thumbs, and we get back okay. Right, okay. So now let's use our Lineagen plugin, and I forgot how to use it. Let's have a look. Use this for user level plugins. Put the plugins mention of your user profile. I think I've already done it. So line profile. Right. So I'm in my line profiles.clj and okay, I've been hacking on it. So let's get a same version number 0.35. Oops. And then what do we do? Clojure checking. To type check many namespaces, add namespaces to your project CLJ like core type. Let's grab this. And we'll add this and grab our namespace name. Okay. And we should be able to go line type check, and you'll see how slow it is. Well, let's just assume this is going to terminate at some point. Oh my god, I'm scared. I think I've run out of RAM. Oh yeah.
Screen just went black for us.
Oh my god. I've only got 4 gig of RAM. Apparently this is not enough to run both core types and Google Hangout. Yeah. So
it's back now. We can see it's initializing for it up front.
Usually, this usually takes a while. It takes about 5 or 6 seconds on a decent machine. This is a penalty you have to pay every line type check, but you only have to pay it once.
Once per project?
Once per run. Okay. Could not resolve var. That should be. Probably compile. Warning. Yeah, I know that. Let's type check it. Oh, yeah. Another thing is, always remember to save your file before type checking. Yeah. You can guess what I just did. I type checked an old version of my file. Right. And so did, oh no, Lineagen type checked the new version. Oh no, 35. Let's just forget about that. So I guess any questions about what I just did? That's kind of all there is to the Lineagen plugin. Unfortunately, you can't just go look and check everything at the moment. And it's kind of to do with how it's not easy to just scan for all typed namespaces because they're just Clojure files. Okay.
If I've got a REPL open with my projects that I'm using for development, is it, am I able to check types from there and skip the startup time?
Definitely, that's what I was doing before. Oh, great, it succeeded. All right, now forget about what just happened. Let's go to the scene. This is what you'd actually do if you're, you know.
So you can check holding from there, and it uses whatever code is loaded.
Right. So the type checking I was doing in this file here, I was actually connected to this REPL where I've already, you know, loaded. You know, back when I had some RAM, it took 7 seconds. Right. But yeah, this is the normal thing you do, and you say if you're an Emacs, this would happen automatically. I think there's an Emacs plugin as well. Yeah.
So when you first tried to type check the core code, it threw some errors. And it seemed like you, in some ways, essentially used the domain and the range that it gave you in that error to fuel the type annotation you put on there. Except you changed it from any number to t/number, something like that. Is that right?
Right. All right. Well, let's see what I did. So let's get rid of our annotation and save the file. We got. Oh my god. Okay. Let's get back off on this for a bit. Can you guys read this?
Yeah. Yep.
Yeah. Okay. Well, we'll keep it like this for now. So we got an error because, well, actually, you should be able to ask what the type is at this point. So I do a little keyboard shortcut, and here's the type of this particular point. I don't know if it will work. No, because it's been relined. But yeah, the type at this point is any.
Right.
Clearly. Anyway, this is a feature that's unique to the Vim plugin, unfortunately. It should be in the code plugin at some point. But yeah, you can't automatically really use the domains to fuel what you're going to put in, because you need to think about which form of int you really want. Like, if you, I mean, I annotated it to be a number to number, so I'm assuming that this is the arity that's going to be most appropriate, so I'd annotate it to be a number.
And the type system generally bottoms out with the Java type system, is that true?
Yeah. Mostly you get things that either are type aliases like this, which expands out to reference types like this, and you also get some special types. So for example, I haven't shown you anything with maps, but you, let's go back to, this might be a better place to demonstrate. So if we type check a map, we get back this heterogeneous map type that says that it's a completely fully specified map with no entries in it. And so yeah, this is bottom out with a reference type because we can have a more expressive type for this. So a map with an entry has one mandatory entry of A, which is a value of 1, and do other cool things like associate. blah, 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 and you basically get what you want. So if you associate a B key onto a map, this is the kind of type that you get. It knows that it has an A and a B key. You can associate things. Also merge things. Oops. And yeah, so this kind of heterogeneous map thing really helps type checking code. So I'll show you one cool example that kind of brings a lot of the things that's cool in Typed Clojure together. So let's get rid of that and we'll do something interesting. So what F for now. I'm going to write something that traverses over an abstract syntax tree, and we're going to represent this abstract syntax tree in terms of hash maps. So kind of the first thing that I would do is tell Typed Clojure how to represent this hash map. That's coming up to. So we can use a type alias. Let's say it's an expression, and at the moment, Typed Clojure isn't very smart, so we need to say that it's a recursive type, where in the body it's an expression. Let's say it's either going to be a heterogeneous map that has an op key, which is if, and has a then key, which is an expression, else key, which is an expression. It also has a test. So this particular syntax here, there's a few things going on. Here. So this quoted map syntax is the same thing as this. Does that make sense?
Does that only lock down the keys that we have and let any other keys through, or does it only allow those keys to be in there?
This is a partially specified map. So this is the same as saying it's not complete.
Okay.
This is actually the default value for complete. So this says it's a partially specified map, which means that it can have extra keys, but if we say things are mandatory, then they must be present, right?
Right.
So in practice, there might be some extra keys, foobar, but the type checker allows for that, and but doesn't prevent you from doing that.
Okay.
So yeah, the quoted syntax is the same as specifying a partial map, which is by far the most common thing to want to specify. So another thing, let's say do expression. Oh, another subtlety is that, let's say I'm using a quote on the right and there's no quote on the left. Because heterogeneous maps can only take keyword values as keys, I've just kind of elided the quote here, and the only thing that's legal in the keys here is a keyword. But actually what this quote means is the value of if, right? But I like to write it like that. That's how it's going to say. So a do AST has expers, which is what? This, let's say it's a vector of expression. Why not? Let's add another one. What's a sane one? Fun, maybe. What does a fun have? defining, I guess. No, let's add locals instead. And then we can... what does a local have? An initial value, which is just anything. It has a name, I think, which is going to be a symbol. Right, so now that we have local, we might as well have something else, I guess, that actually introduces a local. I don't remember what's the best way to do this. I mean, it doesn't matter if we get it wrong, we'll just change the alias. So let's say that it has a local, which is kind of this thing. Let's just say it's a local is a map that has a name. It's a name symbol, and the body is an expression, and then we're gonna have it walk it. Okay. Syntax for def alias.
So if someone wanted to do what you've just done there, by looking at like the documentation and kind of figuring this out on their own,
right?
Where would the place be to go to do that?
What's it called?
I guess this is particularly hard since typedclojure.org is down.
Yep. That's the problem, because if you go api.typedclojure.org, usually it takes you somewhere, but
so that would be the place to go to.
But it redirects to core types, just usual documentation.
Okay.
But, okay, this is one thing you can do. Mailing list, wiki, so there's a wiki with kind of a half-assed user guide on it, which needs to be completely redone. But I guess don't let that discourage you from from using it. So there's a user guide here, which is good to start off with. There's a reference for some types. So it takes you through like the top and bottom types, functions. Yeah, this is slightly out of date, so I changed it to hyphen recently. But for the very recent things, you go to API docs.
Speaking of that, is there a plan to kind of like revamp recommendations, specifically with examples for common things? Because I find like big frustration, like for myself, I think a lot of people, it's like really not super verbosity, but you get to some basic cases, and everything works great, and you end up very quickly with the case like, how do I type this? And it becomes really difficult to figure out.
Right, you want better examples, right?
Yeah, I think
yeah.
Like you maybe like even like right like get the community solution notes. Like,
there is actually a oh my god, no, this is out of date by about a year, but it gives you a decent idea. Oh man.
Is there an IRC channel where we can just drop in examples and have them auto-annotated?
Well, I guess I'll be annotating it if you ask me. Yeah, go to #Typed and go there.
Right.
So here's an example. So there's stuff underneath the Typed Clojure organization. So here's something I did during undergrad, which is sufficiently out of date as well. But actually, it's changed surprisingly little in those 2 years. So you have things like there's no dash, but you can recognize these kinds of things. But this is annotating some Java interop. So what's happening here? So this starts up a new process, does some initializes some objects, and actually here's something interesting. Like this proc here is an instance of process, I guess. Start returns a process. And Typed Clojure assumes that all Java methods return nil. And actually, there's an invariant get out stream never returns nil. It always returns. I mean, it never returns null. It always returns an instance of Java IO writer. So actually, the first time we type check this, Typed Clojure will say it's a possible null pointer exception because we're passing writer something that could possibly be null. So the way to fix that is to kind of reach behind the curtains a little bit and trick core typed into thinking that particular methods can never return null. So here's an example. You use the non-nil return macro that's in Clojure core typed, and you give it a fully specified method, and say for all arities, it's never going to return nil. And yeah, there's a few examples of these kinds of practical issues in this example.
I guess it'd be like really nice to organize a general on a site, right? So like a digs or GitHub repo and help you find the one that matches your thing. So I think something with a bit of, like table of contents, right, or by category, how examples, you're trying to do this kind of thing, you're trying to do that kind of thing. It would be like extremely helpful.
Yes.
I have some of that. Is that true?
It does have some wood, yeah. But again, a bit outdated in some cases. Completely comprehensive. Like what I'm saying is, right, like even if you guys don't suggest the idea, I expect a lot of people would jump in on it, but it kind of like needs to be highlighted that it's missing.
Right, yeah.
That actually brings up a follow-up question that I had, that I was going to ask at the end, but I might as well ask now.
Okay.
A nice segue, which is how can we help?
Oh, well, the most obvious thing that you could do is pick your favorite library, one that you wouldn't mind knowing a little too much about the internals,
Right.
and translating the API in terms of core type types and providing that as a jar somewhere on the internet and telling me. But that is definitely the most valuable thing that you can do for core typed at the moment, because if you've seen my Strange Loop talk, I give an example of the amount of third-party annotations that CircleCI have had to do, and about a third of their annotations out of like hundreds and hundreds. I forgot how many it was, 600. So 100 odd were, or 200 odd were just third-party annotations. So that's yak shaving. That is not cool. And yeah, there's a reason why there's enormous repositories of TypeScript annotations, because it's really annoying to reverse annotate. I guess I'm speaking the obvious here. No one wants to reverse engineer things that we already know have types. So yeah, pick your favorite library, maybe one that isn't insane. Unfortunately, ascribing types to expressions can be pretty insane sometimes, depending on the library. For example, core async was pretty crazy.
Right.
Yeah, right.
Is there a way to tell when you've got the annotations correct?
No, you basically, well, you can either do it two ways. You can do one way, which is adding unchecked annotations. And I can probably show you exactly. So something like, can you see this?
Almost. Maybe one, yeah, that's good.
Okay, well, I might as well go more. I've got extra room. So here's our core async annotations. Sorry, I'll just scroll through it. So it basically consists of a whole bunch of aliases. So say a buffer, something can write type W and read type P, and there's some higher kind of type here. The type function returns some type, right? And these are core async protocols which we've had to annotate. So I'll just scroll up, and here are some annotations for protocols. And these are not actually checked. This should, yeah, this is kind of a bit hacky. There should be something like a no-check annotation. That'll probably appear at some point. But with vars, you have exactly this. So I'll show you some var annotations. So here, here's a var annotations for the buffer function. It's no checked, which means that core typed won't go looking for the definition, and it says something like, yeah, for all types W and R, takes the int and returns a buffer to W for R, WR, right?
We're saying, take our word for it, it works this way.
What was that?
We're saying, trust us, it works this way.
Yes, unfortunately, that's the best that core typed offers at the moment. So there's actually another extension that Typed Clojure can have for run type checking, and it could say you could have a different annotation that says check at runtime, right? And core type would know how to convert this into a function that it wouldn't necessarily check the implementation, it would check every usage of buffer to make sure it adhered to that type. And that's something that's kind of the cornerstone of typed racket. It's what makes it novel, but it's not actually in Typed Clojure at the moment. And it's not actually clear how to implement it either. So for now, we're just stuck with trust me, try not to shoot yourself in the foot, no checked annotations.
Right.
But you can make checks. I mean, if you don't have a no check there, then...
Yeah, so one thing you can do is, say, you could fork core async and kind of massage it so then you can type check it. And actually add the annotations.
So what is it? Just because you aren't working in the core async project itself that you have to do no check, or what is it that forces you to do that?
Yeah, so that's basically it. So all core type does when it sees the dependency, so when you use core async, you're going to have a dependency on this namespace, Clojure core typed async. It's just going to go through this file and eat up all the type annotations. And if you don't have a no check, it's just going to basically warn you and say that it hasn't found the definition. So alternatively, you could have something. Let me turn off. All right. What core async? Async. So alternatively, you could have something this in the core async implementation. So say you wanted to actually make sure that you got all the annotations right, you could for core async add annotations like, you know, here, function handler, blah 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 blah, and actually type check this entire implementation like this. So there's two ways of doing it. Yeah, you're kind of chasing a moving target doing it this way, because you have to fork core async, and as soon as it changes, you have to type check the entire thing.
But doesn't if core async is in your project, doesn't the jar have the source code in it?
So actually what happens in practice is that your namespace is going to depend on Clojure core async. Typed Clojure will bring up Clojure core async, the actual source. It'll then inspect the namespace form, and it'll say, does the namespace form depend on Clojure core type? And the answer will be no. So it'll basically ignore the rest of the file and treat it as if it's unchecked.
Okay, so it would. There's something preventing core type from
It's not even that. It's that it would be useless to. It would be futile to assume that Typed Clojure is smart enough to simply type check it, given the top level annotations. So if there's
So because there would be all kinds of
exactly. If there's a fun here,
I see.
we probably have to go something like some type variable A. I don't know. Oh, really spazzing out. It just folded in on itself. But yeah, you can see that type annotations don't always need to be on the top level. They also sometimes need to be inside the type. So it's a fairly intrusive process.
And then also it would need to have its own no-check annotations for all of its dependencies, I suppose, if it were actually typed.
Right, yeah. Yeah, that's a lot of... And yeah, Core Async is just crazy. So actually, I'll show you probably the most interesting thing with the async annotation. So it's type checking the Go macro. So Go kind of implements this. I don't actually know how it's implemented. It's some sort of state machine which outputs a whole bunch of code. Basically, every Go macro call expands out to a whole bunch of code that has loops, that has funds, it has a whole bunch of things that don't type check correctly. But it turns out the actual syntax that you provide core typed is perfect. Sorry, the actual syntax that you provide Go, like on the top level, is perfect for type checking. So, as an example for kind of bridging the gap between typed and untyped lands, so this is the actual body of the Go macro. So it's this whatever state machine, blah 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 blah. But yeah, we don't want to touch this. This is the expansion. So we wrap it in type checker ignore, and Typed Clojure ignores this enormous macro expansion, which actually happens here. No, it happens here. So this state machine is going to expand out to something that's really not helpful for type checking. But what it actually does is it uses the body. So the actual body of the type, the body that you provide Go, I just wrap in a thunk that I never evaluate. And then I say if I'm currently type checking, there's this flag in core type that tells you if you're running the type checker. So if I'm expanding while I'm running the type checker, then I add this to the output of the Go macro. So what actually happens is core types will end up checking something like, so let's assume that we're type checking this. It'll end up type checking this. And you can see this doesn't actually do anything, but Typed Clojure still wants to type check it. So this is one example of kind of, so you have this problem where you don't want to type check all the way down. So this is one approach that I have of sanely bridging the gap between typed and untyped worlds. But yeah, this is clearly stepping outside the guarantees that the core type gives you. You could have anything in here, and the type checker ignores it. So you've got to be careful. Yeah, so unfortunately, there are kind of two activities when you're annotating third-party libraries. One is annotating the actual vars, and the other one is having wrapper macros like this. And for example, this wrapper macro has an extra annotation that tells you the type of the output channel, which is actually needed if you want to ever use the output channel. And yeah, I mean, clearly there's some extra stuff in this Go macro. So yeah, you have to kind of be a bit fluid in the way that you handle macros. And
so
yeah.
the version of the Go macro is provided by this Cortex namespace. So do you need to use this version of the Go macro if you want to if you want to use core async with like
Yes.
effectively. Yeah.
Yes, this is actually there are for core macros like clojure.core/4. That expands out to some pretty crazy stuff. So in practice, you have to use the typed version, even if you don't add annotations, just because it massages the output a little nicer. Yeah, it's one of the warts with type checking things. So type checking untyped code with macros. Anything else I was going to show you? Scott.
We were halfway through an AS walker.
Oh yes, let's do that. I love this one. Okay, so we've here's an AST. This is a Clojure AST represented with immutable maps. Right. So actually, if you write a nice doc string, you'll get nice documentation. So if we look up the documentation, no. Oh god. Okay, so I press capital K and Vim, and it looks up the documentation of the current form. But if it begins with a capital letter, it opens up a browser and goes to Java doc. So let's use doc. Okay, so this is the nice thing that you look forward to. No, go away. If you actually look up the documentation, and you know, this is pretty much we saw. Yeah, it's already open here. The API docs. This is exactly what is happening in the API docs. So I've got a doc string. Here's the actual type, and you know, at the REPL we can look up types just by looking up the var. So a type alias, just a var, which you just refer like you would in your code. Anyway, so what do we want our function to do? What's a sane thing we could do? So let's add one more expression. Constants. And it can be anything. So this is one of our loop nodes. I don't know, let's sum up all the constants in our language, in our AST. So it's multi-method is going to take an expression and return some. No. Let's say that yes, the only constants we can have are int. Yeah, that's not something. Okay. So let's just type check this, see what happens. Okay, so that works. Alright, so the first thing we're going to do is to this up. So let's implement if. So if we're dispatching through this branch, we've got an if. So we've got, I don't know, some keys as x per, I guess, let's say. And let's take out the then, else, and test. And then add some of the test. Oh, we could do this a little bit better. Map sum over test then else. And apply plus. Right. Type checking. Yeah, that's type checking. Okay. So, yeah, so what's happening here, if I query the type at this point, so if we look at the bottom left, it's going to say it's an expression. And that the expr is actually an instance of this heterogeneous map. So it doesn't actually have a name. but it's our if expression. So it has a test, a then, and an else. So basically, a core type uses occurrence typing to figure this out automatically. And it takes the information that it knows what the input type has to be. It also knows what the relationship between the dispatch function and the dispatch value is. So it basically says, let's refine this union down to maps that have an op key that is, which basically refines it down to this. So let's use the same logic for other things. So you'll notice there's no kind of totality checking, I guess. So it doesn't say, oh, you forgot the do case. So that Typed Clojure just delegates those kinds of errors to runtime. But it doesn't help you with fully specifying what do you call it? Your multi-methods. All right, so second case. Let's do our base case. We've got a constant, then we've got some val, which is an int. So let's just return the val. We've got a do, and a do. Oops. I'll slow down a little bit. That's right. And we can just map over the expressions. And if it's a local, init out of value for an expression. Let's say that's oh no. Let's just say that a local that returns nothing. So 0. And a fun. Let's see. It's a local, which we don't care about at the moment. Some body. So we have a body. So sum the body. Alright. Type check it. Okay. Let's type check. In apparently 4 seconds. Okay, so we've type checked the definition, so now let's type check some examples of actually running it. And I've forgotten what my syntax was. So let's have a look. Let's say we want a sum of if. Actually, that's way too annoying. Let's write some functions that make it. Then else test, and we'll say that make if takes 3 expressions and returns an expression. Yeah, that'll do. So we can say that, and we just build it up as we would expect. Checking. Okay. So we can make an if. Oh, I haven't got any leaf nodes. Alright, I need a constructor for a leaf node. Constants. So a constant, make const. Takes what, an int? Const val I. So we can kind of copy this. Takes an int and returns an expression. Check that. Okay. So let's actually use the REPL experiment. So let's say we want to check that type of make const is, it's an expression, and say that is it's an expression, right? So we can oops. So yeah, let's bring that up. That's useful. Okay. So are we following what I'm doing? It's fairly straightforward manipulation of maps. Are there any questions so far? Cool.
I think we're good.
Go. All right. So let's.
It's fairly straightforward manipulation of maps if you've seen the insides of Scheme or Lisp or Clojure before.
Right. Yeah.
Probably not as straightforward if you haven't seen it.
Yeah. This is pretty. I guess if you think of all these as data types in a more strongly typed language, like this is an if class, a const class, a do class, and you'll kind of see the analogy of what we're simulating when we're writing this in Clojure. And yeah, this is just dispatching on like the class or whatever, so we know which do expression we're talking about in this part. So let's actually just test if this one works. This should be 3. Okay, it actually works. Amazing. Let's type check it.
Nice.
So I ran it, so yeah, it type checked unsurprisingly.
Very nice.
Yeah, that's.
So in a way, we just created our own tiny little typed language.
We created our own AST representation of Clojure. So I guess we could write a little parser if you'd entertain me a minute. So what's a parser? It takes any to an expression, right?
Right.
So I don't know. Let's just write a few cases. Ooh, okay. Let's make this a and some syntax. So let's say if we have a symbol, then we construct. That would be a local binding. So we need another thing for locals. So make local. Yeah, let's get rid of this init. Let's just say a local is just a symbol. That should be there. Local is a name. So we give it a symbol, which is a name, it returns an expression. Okay, so if it's so back to our parsing thing. So if it's a symbol, then we're going to make a local binding representation. Sorry, a local binding AST. If it's a keyword, let's not allow keywords. Let's say if it's an integer, we're going to make a constant. Because remember, our constants are only allowed to be integers for some silly reason. Because I want to add up integers. So, if it's a list, then we either have what? It's either an if, or a do, or a fun. Okay. So let's have another con. So if the first of the syntax, so because we're down this branch, we know it's safe to call first. The first is, what's the syntax? If. Right. Yes. And then let's make a helper function before we go insane. Pass if. So we have an if syntax. Let's say we're going to say this is if, and so this is then. Keep on forgetting the test for some reason. Test then else, and we're going to make an if. What do we need to do? We need to pass the test, pass the then, pass the else, and this takes pass if takes seek call. Oh, it's a bit subtle. I think we want to take in a seek, because lists are seeks. So we can say it's going to take a seek of whatever, and then return an expression. So if the first thing is an if, we're going to say pass if that entire thing. If it's a do, we're going to, well, let's make this a case. Yeah, that's much cleaner actually. Case, do, what is that? Fun. Alright, let's just leave that there for a moment. Pass do is going to take in a sequence of blah and some number of bodies. Make do. I don't think we have. Nope. Let's add make do. So it's going to take any number of expressions, which means that we have any number of these. It's going to return an expression. And if we look back at our definition for do, it's got an op, which is do, and a key expres, which is a vector. So we're going to map v over, oh no. We just need to call vec on it because we've got expressions. Vec on ease. Right? I think that makes sense. So we're passing in expressions, get back a do. Make do. Where are we? Pass do. Okay. And we just need to apply make do to mapping what? Pass over body. Yeah. Let's just do that. And pass.
Is it a sequence of expressions, or do we need it still be a sequence of any?
Yeah. So you mean for the argument of pass do?
That's right. Yeah.
Yeah. So this is going to be like do, and then a whole bunch of syntax. Because remember, this is all we know so far is it's a list, and that it has a do. So yeah, it's going to.
So we'll keep it in the type expression up above. We'll keep it as a sequence of any.
Yes, because this is what we can pass from the past. We can just give it type anything. Because this could be anything. It could be
Right.
symbols, integers, lists.
Right.
Okay. Let's just say I'm too lazy to implement this for the moment, and I'll show you that you can just delegate this to runtime checking. Basically, Typed Clojure assumes that if your program throws an exception, that it basically ignores that branch. And for example, like these two calls both have to return expressions. This one doesn't really, it always returns an exception. So if we type check this, cross our fingers, they either tell us whether we got it wrong. Pass.
Yeah.
Yeah.
Do the case values need to be quoted?
I don't think they do.
Okay.
The case syntax is pretty weak. I'll just show you. Found type errors. Excellent. Type errors. Lots of them. Holy moly. Alright. Int could not be applied to arguments. It smells like a destructuring problem. Alright, so where is it? Aha. Oh, yeah, this is nasty. This is really nasty. Okay. So, let me show you something which is too much information about Clojure. And unfortunately, Typed Clojure has had to follow exactly this design decision. What am I looking for? And so with runtime.java. So here's the underlying implementation of int. And it can handle a whole bunch of objects like null, char sequence, random access. Oh, I forgot to make it readable. But if you see, it gets all the way down to sequential, which is like a flag interface. You would expect this to be like IC, but really, for your code to go down this branch, your code has to implement sequential. And unfortunately, going back to the pass example, we just had that it was a seek, right? And if you look up the actual documentation for seek, it's a Clojure length iSeek. And if we look at the ancestors of iSeek, it extends IPS collection, but it doesn't extend the sequential, right? So we can't actually destructure things of type seek. Like, it's just ill-typed. So I think async can do it. So yeah, if you look in the API, which we might as well do right now. Oh, here it is, async. A sequential seek returned from a Clojure core seek. So this is something that's designed to be a useful type annotation. I'm not quite sure if I should drop the A here and just make this annotation seek. But basically the idea is it has a whole bunch of extra interfaces like iterable, sequential, collection, list, and you should be able to destructure them. So let's add this in a few places. Yeah, that's really a depressing thing, what I just showed you. Hopefully you never come across it, but I guess practically you will. And I'm just waiting for type checking.
Right. I'm still trying to understand what just happened.
Oh.
Talking about sequence and I sequence and A sequence, that's okay. We'll just move on and pretend that never happened.
The gist of it is that
That sequences are not sequences.
That that the interfaces that Clojure provides kind of have weird relationships with the functions that you'd expect them to work with. So in practice, everything that you're going to destructure with is going to implement sequential. For example, something that doesn't implement sequential is a set. So here we go. Nth is not supported on this type persistent hash set, right? I guess if we reify something which is the Clojure lang sequential, we'll get a different error. I know this is interesting. Yeah, we get a different error because Nth has realized that this is sequential, so then it goes down which branch? Yeah, so we go down this branch and it blows up at this seq call because it doesn't know how to create a seq from just something as sequential. I don't know. I don't know if that made any sense, but anyway, the relationships between the interfaces are quite subtle, and yeah, QuarType basically has to play along with this. In summary, if you're going to destructure something, use async, but or maybe even call. I don't know. This is something I haven't quite figured out yet. After so many years, I still don't know exactly what the solution is.
What would be the downside of using, async or call in places where it isn't strictly needed?
So,
would it just be that your type annotation is looser than it needs to be?
well, one general rule, which, like in any typed language, that or any programming, it's nice to have functions that are lenient in their parameters and very precise in their output types. So it would be nice to say that this accepts any sequence, like anything that extends, Clojure lang async should be able to work. But unfortunately, it doesn't.
So in some ways, async is actually stricter than seek, even though it's a union of all those things. So it's kind of like overlapping, but not.
Oh, it's not a union; it's an intersection.
Oh, okay, right.
Yes. Sorry, I skipped over that, but that's a very important thing. That this is similar to if we go to the Java code.
So it's strictly more limited, right?
Strictly more strict.
Right. So this is something like.
So, yeah, right. Sorry.
Any questions?
I was joking while we were waiting.
That makes a lot more sense now. Thank you.
Okay, yeah. So async is stricter, right? And it turns out that, morally, it's actually the correct type. Because maybe I can prove this. So if we go pass if and then reify something that, that implements async. Let's see. I guess it takes us this and then whatever. Let's just whatever. Does reify take it to? I don't know. Right. So yeah, you can see that at runtime, it actually blows up. So if you're using some third-party sequence which is implemented like this, which isn't sequential, this is actually going to blow up. So this is something that QuarType needs to remember, right? So actually, one thing I haven't actually mentioned is that QuarType runs your code while type checking, and it's a quirk of having to analyze Clojure code. Basically, if you analyze Clojure code, you have to run it, otherwise you end up in an inconsistent state. So if you have something that's going to blow up at runtime, just wrap it in a func. Actually, core types can't actually type check reify, so that was useless. But I think, did you get the gist of it? Like,
Right.
ideally, core types would say that this is a type error and that you need to have something like sequential, right? And let's assume that we had an intersection of seek and any. Did
we lose you? I wonder if we with that sequence that it's also in the browser again. You guys really stuck.
Oh.
Are you back now?
Oh, we're good. Okay. I thought I did actually. This is what happened in between. Sure.
That's not a sugar type.
Yes.
Maybe I should add it. So this is probably the most precise. Hang on. This is the least precise type that we can give. It's still type correct. Let's actually type check it. Might actually get this part done in the next 5 minutes. Actually, just do it. All right, type checking.
So while we're waiting for the type checker.
Yeah. Go ahead.
Oh, that is. I'll bring it up again later. We'll finish this first.
Okay.
Next time we can.
Okay. Tell you what, I'm going to take a different approach. Through destructuring, let's say, okay, do something different. Let's say you take any. We're just going to make a vector out of it. We know we can destruct vectors. And that's really depressing. Oh well. But this is clearly never going to run a prototype because we can always destruct them. Alright, now you can ask your question, Dan. I think it was Dan.
Yeah, so just to iterate or reiterate over the procedure for helping out with typed closure. It's 1, pick a library, 2, add some annotations, 3, let you know where the jar is posted. Is that right?
Yeah, put the code on GitHub, and I'll accumulate a bunch of links to the different annotations. And the idea is that people can add your dependency string to their projects and use your annotation.
Would it be helpful to make a pull request to the original library with the annotation?
Yes, it would be. Usually, depending on the project, I suggest like appending .type to the core namespace. So I had Clojure core async .type, and having that as kind of the basic, the base type namespace that you would annotate, and then pushing that to the upstream project.
Okay.
Function class to cannot be object. Syntax. Okay. Oh, that's depressing. Well, maybe it doesn't work after all. Let's cheat. Let's cheat and wait for the creator of core type to make it better. It's surprisingly often when that's the case. You wait a few months and then the feature that you want is there. And you can gradually get rid of no checks.
Right.
I mean, no checks are useful because if you think about it, if you have a no check, it's going to type check the definition, which is one thing. But if you have a no check, it's not going to type check the definition. But if you get the correct type, think of the number of times that you're going to run that function, right? And every time you're going to use a decent, annotation. So no checks aren't bad, aren't really evil. But, yeah. Anyway, grand finale time. Pass.
Yes.
What am I doing? I'm not allowed to use fun because that'll blow up. Is that actually going to work? 6. Oh my god. Alright, type checking time. I just ran it. Alright.
Very nice.
Drum roll.
Yes. Excellent.
I think,
Does anyone else have questions for Ambrose?
okay, done.
I think that was a great finale.
Yeah, I didn't know I was going to do that, but it was fun.
That was fun. Thank you so much for being with us and taking us through this. This has been amazing.
Oh, my pleasure.
Excellent.
Well, thanks for inviting me.
Yeah.
Yeah.
Have a great evening and good luck getting typedclojure.org back up.
Oh no, don't remind me. To be honest, I'm not looking forward to digging through which password I need to change the DNS, and that's the only problem. I just forgot. It was the last time I touched it was literally a year ago when I did the crowdfunding.
Right.
Which was like a year ago, which is nuts actually. Because I'm in Indiana now, which is nuts to think about. But yeah, my life has changed a lot. But yes, great to meet you all. Thanks for coming. Thanks for inviting me. Have a great night. Yeah.
Yeah, you too. Thank you so much.